Alright, so this is 2010 5C. The function g is defined and differentiable in the closed interval -7 to 5 and satisfies g of 0 equals 5. The graph of y equals g prime of x, the derivative of g, consists of a semicircle and 3 line segments as shown above. The question to C, the function h is defined by h of x equals g of x minus 1/2 x squared. Find the x-coordinate of each critical point of h, where -7 is less than x is less than 5, and classify each critical point as the location of a relative min, max, or min or max. Explain your reasoning. So we're given two key points of information here, that graph of g prime, and also that h of x is equal to g of x minus 1/2 x squared. So we're going to use that to find the critical points of h. So we'll also use the derivative of h of x, which is equal to g prime of x minus x. You find that by -1/2 x squared. The derivative of that is x, negative x. And then derivative of g of x is just g prime of x. So we'll set it equal to 0, the g prime of x minus x. And then we'll find out that g prime of x is equal to x. So we'll use this, which we're also given, this interval, -2 to 2. G prime of x there is equal to radical 4 minus x squared. And then from there, we can realize that the only working thing there would be g prime of radical 2, which also equals radical 2. You plug in radical 2 right here, and you get it. And then the other critical point would be up here. We're given it, because g prime of 3 up there is equal to 3. So that satisfies this condition. Both of them do. So there's our critical points, which we're going to use to find relative maxes and mins. Alright, so since we found that our critical numbers were x equals radical 2, 3, I'm going to make a little number line to find where it's increasing and decreasing. This is the graph of h prime, mind you. Radical 2, 3, h prime. Alright, so we're going to find something here. So we'll do h prime of 0. That's less than radical 2. So remember that h prime of x is equal to g prime of x minus x. So g prime of g prime of 0 minus 0, that's equal to 2. Because you see right here. So that's positive. And then we'll do this area right here, so we'll use 2. H prime of 2 is equal to g prime of 2 minus 2. You can see it's 0 here, so that's negative. It's -2. And h prime of 5 we'll use, because we're already given it. G prime of 5 minus 5. That ends up being -6. You can see right here, this is -1. So increasing, decreasing, decreasing, and we'll use that to find our answer. Alright, so to finish things off, we're just going to scribe our answer out so we can get full credit on this problem. So h prime of x is greater than 0 for inclusive of 0 to radical 2 non-inclusive. H prime of x is less than or equal to 0 for radical 2 to 5 inclusive. Okay, so that means that h has a relative max at x equals radical 2, and neither a minimum nor a maximum at x equals 3. Because as we saw in that number line before, right here, it was increasing, decreasing, decreasing. So this has to be a max, and this is neither. So that's the answer to our problem.